We recognize this as a calorimetry problem because we have two things that are changing temperature. We have a water bath that starts at 35 degrees C and a piece of hot copper that starts at 235 degrees C. The copper cools down to a final temperature of 65 degrees C, which is also the final temperature of the water. So we have two values of delta T. Delta T for the hot copper is going to be calculated as TF minus TI, and the final temperature is 65, and we started with a temperature of 235 degrees C, so our delta T for the hot copper is a minus 170 degrees C. For the water bath, we have the same final temperature, but we have a different initial temperature. So delta T, TF minus TI. Our final temperature is 65. Our initial temperature is 35. So our delta T for the water is a positive 30 degrees C. We apply the concept of the first law. The energy of the universe remained constant, which, as it applies here, is that the heat gained by one system added to the heat lost to another item has to sum to zero. We know that the water is gaining heat because it's increasing in temperature. Here, our metal copper is losing heat. Each of these terms is obtained by applying the equation that the heat is equal to the mass times the specific heat capacity times delta T. For the water bath, our mass is 89 grams. The specific heat capacity of water, we'll use the value with units of calories per gram degree C, just to make the math easier. And our delta T was determined to be 30 degrees C. For the hot metal, we're trying to calculate the mass, and we multiply that by the specific heat capacity in units of calories per gram degree C, because we want to match the units over here. And then we apply that by delta T, which is a negative 170 degrees C. And all of this needs to sum to zero. Doing the math, this comes to be 2670, to which we add a value of the mass times a negative 15.64, because that's what we get when we multiply our heat capacity times our delta T. And again, this sums to zero. So we add 15.64 times m to each side. We have 15.64 times m is going to be equal to 260.70. We can solve for m. And if we do the math, this comes out to be 170.716 grams. We can justify just 2 sig figs in our answer. So this becomes 1.7 times 10 to the second grams.